Welcome back. We're in the process of writing Little Man Computer using C++, and we've got as far as adding all of the operations except branching. So that's what we're going to do today. So there are three branching operations. There's the unconditional branch, which will just change the program counter independent of any other factors. There's branch of 0, which will change the program counter if the accumulator is 0. And there's branch of positive, which will change the program counter if the negative flag is false. And in all three cases, the program counter will be changed to the address specified. So, where are we? Let's find our tests. Here are our tests, and we've just completed subtraction. So we can continue by adding a test for unconditional branching. Is that? Yes, okay, we can call it unconditional branching. So test unconditional branching changes the program counter. Is that what they've called it, the program counter? I would imagine so. Yes. Good. So let's go to name. Let's add it to the tests list. And we shall start, as usual, with the assertion that some random number, 77, is the value of the program counter after we finished whatever we're going to do to it. In this case, the branch. So if we call make, we will clearly see that we have no computer yet. So we'll give ourselves a computer. That should be enough to compile, except that we have no program counter, unsurprisingly. So we will then create ourselves a program counter. Let's make that the top item. And that should then compile. And it does. So we have to set some memory. No, that's not how we do it. We have to set called branch. Is that the name? Yes, we'll just call it branch with the memory address 77. Is that the correct formulation? Yep. And slightly too many key presses. That'll do. So we're creating a computer. We call branch 77 on it. We should probably, just to be on the safe side, make sure that the program counter starts from a known value. And then hopefully we will just be given the chance to add branching. So branch const int address, which should then compile. No, we have no implementation. That's fine. That's easily rectified. Branch const int address and our little cheat to make sure compiling doesn't fail due to an unused variable. And there we have it. We have got everything compiling with the full test. We run it, and of course the test fails. And this should be straightforward to pass the test. We can say program count equals 77. Make is fine. Make test passes the test. We of course have the irritation of 77 being essentially a duplicate because it's a value in the test as well, and it's value in the address. So here we can just say address, and we can check the test pass, and we do. Let's just check that I didn't accidentally error anything there. Yes, good. So now we have unconditional branching. The next thing to check is branch if 0. So test branch if 0, branch if positive, yes, branch if 0, branches if the accumulator is 0, and we shall assert equal, I'll move to 78 this time. That will require saving before we do anything. We need a computer. We need to actually run the test. And we see it fail. We need to give the test a name. Like that. And the test now fails as expected. We actually need to set the accumulator. Let's set the program counter to a known value. Let's set the accumulator to 0, and then we shall branch if 0 to 78. That should now fail because I've missed an equal sign, and now it will fail because we have no branch of 0 as expected. So we will create branch if 0, and we shall preempt the compile failure and just implement branch if 0 with a trivial implementation. That, and we shall find that the test correctly fails. We can then make it pass by setting the program counter equal to 78. Let's not be quite so aggressive there. That passes. We shall then remove the duplication, tidy things up, and check the tests still pass, which they do. And now we need to test the alternative case for branch if not 0. Branch if 0. does not branch if the accumulator is not 0. That's a relatively straightforward change. We can change the accumulator to 1. We can change our assertion that the program counter should remain on 0, and we shall, as usual, forget to add the test to our list of tests. We shall run the tests and we shall find the correct failure. We shall then say if accumulator equals 0, this series I appear to be in the mood to set curly braces on single line if statements as well anyway, even though it's not strictly necessary. Today I think it's clearer. I will change my mind tomorrow as usual. So there we have branch if 0 not branching. Excellent. And then our final branch is branch if positive. And we can do that by creating another test. Branch if positive branches if the negative flag is false. So we shall assert equal 79 with the program counter. That will then fail with no computer. We can create one in the usual manner, like so. We will then fail due to not having added the test to our list of tests to run. The test now fails with no name, which we shall steal from here. Now fails with a name, and we can fill in the rest of the test. So we want to branch if positive to 79. And we want to initialize the program counter to 0, the negative flag to false. And then see the test fail due to the lack of a branch if positive method, which we shall add. Assuming I can type. Again, constant address, and we shall preempt the compile failure or the link failure by putting a simple implementation into our code. Like so. That should now fail genuinely. Have we got a typo? Is positive, that's why. Well done, compiler. And now it genuinely fails for the right reasons. We can then set the program counter equal to 79. We can check that the test passed, which they do. We can remove the duplication. like so, and we still pass. However, we're not quite done yet, because we have one final test for the case where the negative flag is set and we don't want to branch. We shall steal the code. Positive does not branch if the negative flag is true. And so this time we can change to have the other test set up. So program counter is 0, negative flag is true. We branch if positive to 79, which we won't be doing, so the program counter remains unchanged. And then we can add the test. And we should hopefully find it fails, and it does, as expected. And we just need to say if negative, what do we like there? If negative equals false, or if not negative. I think that's clearer in this instance. So we shall leave it there. And all of the tests pass. Excellent. And there we go. So we've now done our 3 branching instructions. And we can git commit, add branching instructions. That looks like it's the correct spelling. And there we go. And we've now done all of the instructions here and the relevant registers and flags and memory, with the exception of halt, which really is an operation that little man will be doing, and dat, which is just an interpretation of the assembly language. So we're probably in a position now to move on to developing the little man that operates our computer. But that's an activity for next time.